Hello, and welcome to a special deep dive report. Today is December 13th, 2025, and if you look up at the night sky, you are looking at a crime scene, a laboratory, and a mystery all rolled into one. We are tracking an event that is currently rewriting the textbooks on interstellar dynamics. As Earth races along its orbit at nearly 30 kilometers per second, we are currently involved in a high-speed chase with a visitor from the deep cosmos. I'm talking, of course, about the interstellar object 3I Atlas. This isn't just another rock tumbling through the dark. This is a hyperbolic anomaly that has astronomers from the European Space Agency to NASA's Jet Propulsion Laboratory working double shifts. We are now in the final phase of its visit. The object is approaching its point of closest approach to Earth, which will occur on December 19th, just 6 days from now. But before we get into the physics of this encounter, if you want to stay ahead of these breaking cosmic updates, make sure you hit that subscribe button and turn on notifications. We are covering this situation hour by hour as the data comes in. Let's look closer at the data regarding where this object is right now. 3I Atlas is currently positioned in the constellation Leo, shining with an apparent magnitude of 11. To the naked eye, it is invisible, lost in the black canvas of space. But to a telescope of even moderate power, it is a distinct, fuzzy point of light that refuses to behave like a standard comet. It is currently located about 270 million kilometers from us. To put that in perspective, that is nearly twice the distance between Earth and the Sun. It sounds far, and in terms of collision risk, it is perfectly safe. There is zero chance of impact. However, in astronomical terms, it is close enough to be scrutinized. And what we are seeing is baffling. The geometry of this encounter is creating a fascinating illusion. 3I Atlas actually passed its perihelion, its closest point to the Sun, back on October 29th, 2025. At that time, it dipped to within 1.36 astronomical units of our star, enduring the intense solar heat before slinging back out toward the void. Usually, this is when a comet fades. It moves away, it cools down, it goes quiet. But 3I Atlas is different. Because of Earth's own orbital motion, we are currently catching up to the comet from behind. We are effectively racing it. This orbital geometry creates the illusion that the comet is approaching us for an imminent encounter, even though it is technically receding from the Sun. This unique perspective is giving us a front-row seat to the comet's outbound leg, a phase where comets often reveal their internal structure as the heat soaks deep into their core. So, what does this actually mean for the observer? It means that for the next week, the viewing conditions are optimal, but the object itself is behaving erratically. We are tracking a velocity of roughly 210,000 kilometers per hour. That is a hyperbolic excess velocity that screams interstellar. This object did not originate in our Oort cloud. It didn't form from the same protoplanetary disk that built Earth, Mars, or Jupiter. It is a wanderer, ejected from a distant star system, perhaps billions of years ago, drifting through the interstellar medium until gravity snagged it into our neighborhood. And now it is leaving. But here is the crucial detail that has the scientific community on edge. The trajectory is too perfect. When we model the path of a standard comet, we account for the gravitational pull of the Sun and the planets. It's a complex but solvable equation. 3I Atlas, however, is exhibiting what we call non-gravitational accelerations. In plain English, Something other than gravity is pushing it. Now, usually this is caused by outgassing, jets of gas erupting from the surface acting like thrusters. We see this with comets all the time, but the acceleration we are measuring for 3I Atlas is smooth, consistent, and seemingly adjusted. It's almost as if the object is correcting its course. This contradicts what we previously thought about the behavior of interstellar objects. When Oumuamua passed through in 2017, we saw similar non-gravitational acceleration, but 3I Atlas is displaying it with a magnitude and precision that is harder to explain away with simple thermal outgassing models. The gas jets we do see, which we will discuss in depth later, are episodic and chaotic, yet the acceleration remains strangely uniform. This has led to some bold hypotheses. Astrophysicist Avi Loeb has gone on record noting that the probability of this being a purely natural object, given the specific combination of its orbit and its acceleration, is less than 0.005%. He calls it a messenger from the abyss. While that is a speculative stance, it highlights the severity of the anomaly. We are looking at a trajectory that feels less like a random tumble and more like a flyby. I want to pause here and ask you, do you think we are too quick to look for artificial explanations, or are we too afraid to admit when nature looks engineered? Let me know your thoughts in the comments below. I read them, and this debate is heating up. Now, let's talk about the visual data coming in from the observatories. On December 12th and 13th, literally in the last 24 hours, telescopes from Gemini North in Hawaii to the Hubble Space Telescope have captured stunning new images. The comet has brightened significantly. We are seeing a coma, that's the fuzzy atmosphere around the nucleus, that has expanded to nearly 100,000 kilometers in diameter. That is roughly 8 times the diameter of Earth. Think about that. A ball of gas 8 times the size of our planet, generated by a nucleus that is likely only a few kilometers wide. The structure of this coma is also peculiar. It is highly symmetric. Usually, the solar wind pushes the coma back, creating a distinct bow shock and a tail. But 3I Atlas currently shows a symmetric coma with almost no visible tail in the optical spectrum. It looks like a glowing green orb floating in the darkness. This symmetry suggests that the outgassing is happening uniformly from the entire surface, or that the dust particles are incredibly fine, behaving differently than we expect. The gradients of light within the coma are smooth, shaped by the solar wind, but maintaining a cohesive, spherical integrity. However, the European Space Agency's JUICE probe, which is currently en route to Jupiter, has managed to record interactions between the comet and the solar wind from a different vantage point. Its sensors picked up magnetic disturbances, ripples in the plasma environment as the comet passed. This confirms that 3I Atlas is interacting with the Sun's magnetic field, but the X-ray data from ESA's XMM Newton Observatory adds another layer to the puzzle. They detected a spherical X-ray glow around the comet. Comets do emit X-rays when solar wind ions slam into their atmosphere, but usually we see jets or distinct hotspots. 3I Atlas is glowing uniformly in the X-ray spectrum. It's a cold object wrapped in a hot blanket of high-energy interaction. This brings us back to the central mystery of the December approach. As we close the gap to that 1.8 AU distance on December 19th, we are effectively peeling back the layers of this object. The fact that it fragmented after perihelion yet retained its integrity is another massive red flag for standard models. Typically, when a comet fragments, it disintegrates. It turns into a cloud of debris and fades away. 3I Atlas appeared to fracture, yet the main body remains solid, and the fragments seem to be moving in formation. It hints at a material strength that is far higher than the dirty snowballs we are used to. Is it made of metal? Is it a rock with a unique crystalline structure? Or is it something else entirely? The timing of this visit is also uncanny. It arrives just as our detection capabilities have reached a new peak. We are seeing things now that we would have missed 10 years ago. The greenish glow we mentioned is standard for comets with diatomic carbon, but the intensity of it, combined with the lack of a dust tail, creates a spectral signature that is incredibly pure. It's like looking at a neon sign in the desert. As we move into the next chapter of this investigation, we need to prepare ourselves for the chemical reality of this object. Because what the spectrometers are picking up isn't just water and dust. It's a cocktail of organic chemistry that is so volatile, so abundant, and so misplaced that it challenges our understanding of how life's building blocks are distributed in the universe. We are seeing methanol, alcohol, on a scale that is hard to fathom. We are just scratching the surface of this encounter. The physical behavior of 3I Atlas is strange, but its chemical composition is where the story truly takes a turn into the unknown. In the next part of our deep dive, we are going to analyze the chemical fingerprint of this visitor. We will explore why scientists are using words like rampaging to describe the methanol output and what that green glow is actually telling us about the object's origins. If you're finding this deep dive valuable, please leave a like on this video. It helps the algorithm share this scientific data with more people who need to know what's happening over our heads. Stay tuned, because the chemistry of 3I Atlas might just be the smoking gun we've been looking for. As we established in our analysis of the trajectory, Comet 3I Atlas is not behaving like a typical visitor. Its orbit is hyperbolic, its acceleration is anomalous, and its visual appearance is strikingly symmetrical. But if the movement of the comet is a riddle, its composition is a revelation. We are now going to shift our focus from the telescope eyepieces to the spectrographs, the instruments that break light down into chemical fingerprints. And what we are finding there is, frankly, stunning. Let's look closer at the data coming from the spectral analysis. When astronomers point their instruments at a comet, they are essentially sniffing the gas that boils off it. Usually, we see a standard recipe: lots of water vapor, some carbon dioxide, maybe some ammonia and methane. It's the standard dirty snowball mix of the solar system. But 3I Atlas is serving up a cocktail that is far more potent and far more mysterious. The headline finding is methanol. Methanol, or wood alcohol, is a simple organic molecule. We find it in comets often. But in 3I Atlas, we aren't just seeing traces. Scientists have detected unusually high levels of methanol rampaging far beyond the nucleus. The term rampaging isn't one you often hear in dry scientific papers, but it captures the violence and the scale of what is happening. The methanol signal is incredibly strong, and crucially, it is persisting at distances from the nucleus where it should have dissociated or faded. This contradicts what we previously thought about how cometary comas function. Typically, complex molecules like methanol break down quickly when exposed to the harsh ultraviolet light of the sun. They split into simpler radicals. But around 3I Atlas, the methanol seems to be surviving, or perhaps it is being replenished by a source we can't see. Some models suggest that icy grains are being lifted off the surface and are sublimating, turning from solid to gas, thousands of kilometers out in the coma, releasing fresh methanol as they travel. This implies the comet is shedding its skin in a way that creates a massive, alcohol-rich halo. But the methanol is just one part of the puzzle. The most visually striking feature of 3I Atlas, that eerie electric green color, comes from diatomic carbon, C2. This is a molecule made of two carbon atoms bonded together. When sunlight hits C2, it fluoresces, emitting that characteristic green light. We've seen green comets before. The Green Comet C 2022 E3 TF was a recent example. However, the intensity of the C2 emission in 3I Atlas is off the charts relative to its dust production. Here is the crucial detail. Usually, a comet that is outgassing this much gas is also throwing out a lot of dust, silicate particles, rocks, grit. This dust reflects sunlight and creates a white or yellowish tail. 3I Atlas, however, is remarkably gas-rich and dust-poor. It is a ghost. It is pumping out massive amounts of carbon and organic volatiles, but very little solid debris. This suggests a composition that is almost entirely icy or volatile, lacking the rocky matrix that holds most comets together. It's like a block of frozen atmosphere rather than a dirty snowball. This unique chemistry, high methanol, high diatomic carbon, low dust, points to a unique origin. It suggests that 3I Atlas formed in a region of a protoplanetary disk that was incredibly cold and rich in carbon and oxygen, likely far further out than our own Kuiper belt. Or, more tantalizingly, it formed in a completely different stellar system with a different chemical abundance ratio. This is the panspermia angle that has astrobiologists excited. Methanol is a precursor to more complex organic molecules, the building blocks of amino acids and life. If objects like 3I Atlas are common, and if they travel between stars seeding these compounds, they could be the cosmic delivery trucks of life. But the mystery deepens when we look at the physical structure of the outgassing. We aren't just seeing a uniform cloud. High-resolution imaging has revealed episodic gas jets that create what astronomers are calling spider legs. These are dynamic, filament-like structures that extend from the nucleus into the coma. They change shape over hours, twisting and bending under the influence of the solar wind. So, what does this actually mean? It means the surface of the comet is active in specific, localized regions. It's not melting evenly like an ice cube. There are vents, or active areas, that are turning on and off as the comet rotates. The spider legs appearance suggests that these jets are interacting with the magnetic field of the solar wind, getting twisted into spirals. This dynamic behavior indicates a complex surface topography, perhaps ridges, craters, or chimneys, that channels the gas into these distinct streams. And then there is the issue of fragmentation. As we mentioned, after its perihelion passage on October 29th, the comet appeared to fragment. In standard models, this is the beginning of the end. The nucleus cracks, surface area increases, outgassing spikes, and the object falls apart. But 3I Atlas defied this death sentence. It seemed to split or shed a large piece, yet it retained its overall integrity. The fragments didn't drift away into a debris cloud. They remained gravitationally or structurally bound. Or perhaps the fragmentation was actually a massive outburst of material that looked like a split, but was just a cloud of dense gas. This resilience hints at unusual strength. If it were a loose pile of rubble, a rubble pile comet, tidal forces and thermal stress should have torn it apart by now. The fact that it survived a 1.36 AU perihelion passage and a fragmentoron event suggests the core is monolithic. It is a solid, coherent body. This brings us back to the artificiality debate. A solid, manufactured object would withstand stresses that would crumble a natural ball of ice, while the chemical evidence strongly supports a natural, albeit exotic, origin, frozen volatiles. The structural integrity is a data point that refuses to fit neatly into the fluffy comet model. The unconventional chemistry we are seeing, the raging methanol, the pure carbon glow, might be the signature of a world we can't even imagine, a world where the oceans are made of alcohol and the sky is thick with carbon. 3I Atlas is a sample of that world, frozen in time and delivered to our doorstep. Building on this, the behavior of the coma and these spider-leg jets provides a segue into an even more shocking discovery. While we were focused on the chemistry of the main body, looking for the secrets of its composition, something else appeared in the data, something that wasn't there before. The spider legs might not just be jets. They might be a connection to something else. In the next chapter, we are going to investigate the phantom twin. Just as we thought we were understanding the solitary journey of 3I Atlas, NASA dropped a bombshell. It might not be traveling alone. We are going to look at the evidence for a sister comet and the implications of a double intrusion from interstellar space. If you have any theories on why a comet would have so much methanol, drop them in the comments. Is it just exotic chemistry? Or is there a biological process at work? I want to hear your take. The chemical anomalies of 3I Atlas, the methanol halo, the carbon glow, the lack of dust, were enough to rewrite the textbooks. But just as the scientific community was scrambling to update their models, a new piece of data emerged that turned this from a scientific curiosity into a full-blown mystery. We are no longer just talking about a single object. We are talking about a potential duo. Let's look closer at the data released by NASA just 48 hours ago. In the process of tracking the trajectory of 3I Atlas, deep field surveys detected a second, fainter object moving on a parallel track. This sister comet is racing alongside 3I Atlas, matching its hyperbolic velocity and vector with uncanny precision. This is not a fragment that broke off last week. The distance between them suggests they have been traveling together for a long time, perhaps entering the solar system as a binary pair. This contradicts what we previously thought about interstellar objects. We assumed they were solitary wanderers, ejected alone from chaotic star systems. The odds of capturing one are low. The odds of capturing two at the same time, moving in formation, are astronomically small, unless, of course, they are not random wanderers. The existence of a sister object forces us to reconsider the fragmentation event we discussed earlier. Was the breakup actually the separation of a binary system, or have they been a pair for millions of years? The presence of a companion adds a terrifying layer of complexity to the orbital dynamics. If 3I Atlas is experiencing non-gravitational acceleration, that mysterious push we identified in the first chapter, does the sister object show it too? Early indications suggest yes. Both objects appear to be under the influence of forces that cannot be explained by gravity alone. If it were just outgassing, we would expect random chaotic deviations. But for two separate objects to exhibit similar, synchronized, non-gravitational shifts, that implies a shared mechanism. Here is the crucial detail that has the internet buzzing: the synchrony with a recent gamma-ray burst. Around the time 3I Atlas passed perihelion, high-energy satellites detected a burst of gamma radiation from the general direction of the comet's origin. Scientists are extremely cautious here. Correlation does not imply causation. Gamma-ray bursts happen all the time in the distant universe, but the timing has fueled speculation. Could the anomaly be related to a high-energy event that activated these objects? Or is it a coincidence of cosmic proportions? Avi Loeb's hypothesis of artificial origin suddenly gains a new dimension. If you were sending a probe to another star system, you wouldn't send just one. You would send a fleet, or at least a backup. A sister comet could be a secondary unit, a communication relay, or simply a redundant system. The natural explanation is that a large parent body was torn apart by a star in its home system, and these two shards were ejected together. But the artificial probability, however small, refuses to go to zero. The sister discovery also sheds light on the spider legs phenomenon. If there are two objects, the gravitational interaction between them could be perturbing the gas clouds, creating the twisted, dynamic structures we see in the coma. The legs might be tidal streams of gas being pulled between the two bodies. It's a dance of ghosts in the dark. So, what does this actually mean for the December 19th approach? It means we are looking for two signals, not one. It means the mass estimates for 3I Atlas might be wrong because we were modeling it as a single body. It means the collision threat, while still zero, needs to be recalculated to ensure the companion doesn't have a wider debris field that could intersect Earth's orbit satellites. The double intrusion theory is now the leading topic in astrophysical circles. Is it a coincidence, or is it part of a larger phenomenon? We are seeing a swarm behavior. First Oumuamua, then Borisov, now 3I Atlas and its twin. The frequency of these visitors seems to be increasing, or perhaps we are just getting better at seeing them. But the sister implies a structure to this influx. It suggests that the interstellar medium isn't just a void with occasional rocks. It's a highway, and traffic is picking up. Videos from amateur astronomers are starting to flood YouTube, showing the trajectory in real time. You can see the main body of 3I Atlas, bright and green, and if you squint, or if the exposure is long enough, a faint, ghostly smudge trailing or flanking it. That smudge is the sister. It's real. It's there. And it's watching us just as closely as we are watching it. But while we look up at these two silent travelers, a silence of a different kind has fallen closer to home. A silence that is far more disturbing than any comet. As we try to decipher the signals from 3I Atlas, we have suddenly lost a signal from one of our own. This connects to a developing story that is breaking right now. The mystery of 3I Atlas isn't just about what is happening 270 million kilometers away. It's about what is happening right here in our own solar backyard. We have received reports that a major NASA spacecraft has gone dark, and the timing, just after it observed the comet, is suspicious, to say the least. In the next chapter, The Martian Silence, we are going to investigate the sudden loss of the Maven orbiter. Why did it stop talking? What did it see before it went offline? And could the anomaly that silenced a Mars probe be connected to the anomaly approaching Earth? This is where the science meets the thriller. If you're enjoying this coverage, make sure you're subscribed. You don't want to miss what happens next.